adding fractions with unlike denominators, okay? Who remembers? It's been 2 days. Who remembers what we need to do here first?
You gotta multiply.
It says draw a rectangular fraction model to find the sum. Simplify your answer if possible. Okay, first step, I really want you to rewrite the problem with no numbers in it. Okay? And we're going to draw a couple boxes. This is why I really like this board, because it draws a box for me. Is that blue dark enough? Can you see it?
Yeah.
Okay. All right, so now what I'm going to do is I'm going to copy 1/2 down here with a long line and 1/3 down here with a long line. How many of you were gone on Friday? Oh, good. Okay. Now, we're going to make equivalent fractions here in a minute. Okay? You got that much done? Okay. Divide this one in half and shade 1/2. And then divide this one into thirds and shade 1/3. Okay, got that much done? All right, now I want to find a common denominator. Does anyone remember the little trick we used to find the common denominator?
Multiply.
Table 3.
Didn't we just cross?
Well, we are going to move these lines over, but before we do that,
We cross
oh, no, that's the next step. I got to figure out what to put as my new denominator, though.
we multiplied the bottom of
Uh-huh. So we multiply the denominators? So what's 2 times 3?
6.
Okay, get the new denominator on there. And you're actually going to write it 5 times. This will all start coming back to you. Okay? Now I'm going to show 6 on both boxes. Okay? Remember, you're just going to make 2 horizontal lines on the first one and 1 vertical line on the second one. That should give you 6. Okay? Now, technically, boys and girls, you could just count the number of shaded boxes and write your answer. But remember I said we're not going to make these boxes very long, are we? So let's solve it numerically. How do you make equivalent fractions? Multiply. So I'm going to multiply 2 times something equals 6.
3.
And hint, it's right here. Okay, so that's a 3. Okay, and 3 times something equals 6?
2.
And it's right here. So it's the opposite. Somebody asked me this morning if you're always just going to use the other one. If you multiply your denominators to find a common denominator, the answer is yes. Okay? All right, so this is going to be 2/6. Okay, now do you remember I could take 3/6 and write it here and 2/6 and write it there? But we have another way of doing it that's really kind of fun. All right? So that's what Elodie was talking about. What was she talking about?
Talking about the cross.
Yeah, we're going to cross multiply. So 1 times 3 is 3. And 2 times 1 is, and that should be the same thing I got. And now can I add these fractions? So what's 3 plus 2?
5.
Okay? And that's going to be my answer. You cannot simplify it. Okay? You can make 6 smaller, but you can't make 5 smaller. All right. How are we doing? Okay, speaking of not being able to make 5 smaller, I want to review prime numbers with you. Okay? And please do not write this. Just pay attention to what I'm doing. And focus. Okay? So, We're talking about factors. Two numbers you multiply together to get 2 as your answer, or 3 as your answer, or 4 as your answer, okay? The only 2 I can use for any prime number are 1 and that number. There's nothing else I can multiply together to make 5, is there? That's it. So that's what makes it a prime number. The others are called composite numbers. Okay? Look at this. So 1 times 4, what else do I have? 2 times 2. So that one is not a prime number. Okay? So somebody else said, what about 7? 1 and 7, that's it. So then somebody said, oh, it's the odd numbers. Let's see if it's the odd numbers. 1 and 9. And 3 and 3. So, is it the odd numbers? No. It's just certain numbers, like 11 and 13, 17, 19. Okay? Maybe 23. But there's not very many large ones. Okay? All right, so I'm going to erase all that. That's just a little side note. Some of you learned that in 4th grade. Raise your hand if that's a review for you. Okay? We might do IXL on that later on, but we'll wait and see. Okay? Let's do the next problem. All right. Step 1, rewrite the problem without any numbers. Now I'm going to make the boxes. Remember, when you make the boxes, it's easier to do one line at a time. Do you remember that part? Okay. Okay, then I'm going to take 1/3 and write it down here. And 1/5. Okay, so we're going to divide this one into thirds. Okay? Thirds. And this one's going to be fifths. Now, I made a rule this morning during block 1. If it's higher than fifths, we are not drawing it. That's just a waste of time. Sound good?
Yeah.
Okay, so let's shade 1/3. And shade 1/5. So what would a common denominator be for 3 and 5? How about table 2 back there? So this is, did I say this is 1?
Yeah.
So 1, 2, table 3. Obed, Roberto, Valentina, Miguel. What's a common denominator for 3 and 5?
12.
No?
15.
15? Good. How'd you get 15? What'd you do? 5 times 3. Okay. So I'm going to write 15 5 times. I don't think we're going to forget it after we write it that many times. Okay, next step would be to make 15ths out of both of these. So I'm going to draw the 4 horizontal lines in the first shape and the 2 vertical lines in the second shape. All right. Now, how do I make equivalent fractions? Multiply. So since I multiply my denominators, I just get to choose the other one. So 5 is what I write here. And 3 is what I write here. It only works when you multiply your denominators. Okay? And at the end of the lesson today, I'm going to show you a different way to do it for when you don't multiply your denominators. Okay, so how are we doing? So I can take this 5/15 and write it here, except I really like that cross multiplying thing. So 1 times 5,
5.
and 3 times 1, and that gives me 8/15. 8/15 cannot be simplified because 8 is not divisible by 3 or 5, and 15 is not divisible by 2 or 4. Okay? So we're done with that one. Let's go down to another one. All right, step 1, rewrite the problem without any numbers. Then draw your boxes. So 1/4 goes below the first box, 1/3 goes below the second box. Okay, so divide the first shape into fourths. And shade 1/4. Second shape into thirds. And shade 1/3. So table 2, what's your common denominator for 4 and 3?
12.
How'd you get it?
4 times
4 times 3, good. Okay, so get all this written down. Sometimes it's not going to work out because we got to make sure we do horizontal on the second shape. Okay? No biggie this time, but if it doesn't look right, that's why. Okay? All right. Not mentioning any names. All right, so now I got to make 12ths. You might have to draw the same thing twice. And that should be 12ths. 4, 8, 12. Okay? 4 times what equals 12?
3.
And 3 times what equals 12?
4.
And if I do the cross multiplying, 1 times 3 and 4 times 1. And that gives me 7/12. 7 is a prime number, so unless the denominator is a multiple of 7, you can't simplify it. Okay, now what new rule did I make? If it's over 5, we're not drawing it. Okay? So this one we'll solve numerically. Table 1, I feel like it's your turn. What's my common denominator for 3 and 7? 21. Now, if, I'm going to tell you right now, this is not the only class that said it was 10. And what mistake did they make? They accidentally added. You're not going to add when you're choosing the denominator, okay? You're going to multiply. Now, let's do the cross multiply. What's 1 times 7?
7.
And 3 times 1? And what do we have for an answer? 10 21sts, okay? Everybody say it, 10 21sts.
10 21st.
Okay, let's look at the next page. Now be careful, make sure you're on the back of the problem set. Someone else got on the back of the homework by accident earlier today. So make sure the problem is 3/4 plus 1/5. Okay? How's this one different?
The numerator.
Yeah, there's 3 for a numerator. So do you remember what those fractions are called that have 1 as a numerator? You're really close. Unit fractions. Okay? Unit fractions. 3/4 is not a unit fraction, so things are going to look a little different on it. Okay, rewrite the problem and draw your boxes. Okay, so 3/4 will go here, and 1/5 will go here. And I'm going to divide this into fourths. How many will I shade this time?
3.
Very good. And I'll divide this one into fifths. Now, do you think this is more than one whole? You think? Close. It's going to be close. All right. So what's my common table 3 in the back? What's my common denominator for 4 and 5? 20. Good job. Say 20 in Spanish. Okay. So you're going to write 20 5 times. Okay, now I'm going to draw 4 horizontal lines and 3 vertical lines, and hopefully that's going to be 20. Okay. Am I rushing you or are you good? 4 times what equals 20? 5. So what's 3 times 5?
15.
Okay. And 5 times what equals 20?
4.
Okay. And it still works cross multiplying because 3 times 5 and 1 times 4. And what's my answer?
220.
Is it more than one whole? No, but it's very close, isn't it? All right. So the rule says you don't have to draw anything on the next one. Okay? So why don't you solve this one on your own and then check it with mine. I'm going to pause it while you work on it. So your denominator is what, boys and girls?
21.
Okay, and then 2 times 7.
14.
And 3 times 2.
6.
And that gives me 20 21sts. Okay? All right. Well, now the reason why you don't want to do it backwards is because when we get to subtraction, you can't switch them around. So that's why I always start on the left and go down, and then start on the left and go up. That's the reason for that. Okay? All right, let's look at this right down here. Okay, so we are not going to draw a picture here. I'm going to show you a different way to choose a denominator. Okay, so we're going to do the same problem twice. All right. Jamal used 1/3 yard of ribbon to tie a package and 1/6 yard of ribbon to tie a bow. How many yards of ribbon did Jamal use? Okay, so what is my problem here? My addition problem. 1/3 plus 1/6. And I want you to write that twice, because we're going to solve it 2 different ways. And then if we have time, I'll teach you some other stuff. Okay, so we've been using a common denominator of what here? 18. So that's the first way we'll solve this problem. Okay? And nothing changes on this one. Okay? So we'll do 1 times 6 and 3 times 1. And that gives 9/18. So 9/18 can be simplified. What's that first thing I tried? Ooh, I see somebody with their hand up. Go ahead and tell me what you think. It's a half. Did you remember that 9 plus 9 is 18? And 9 times 2 is 18? And the doubles and the times 2 facts match the halves. Remember that? It's been a while, okay? So my answer to this is 1/2. Now I'm going to show you another method. You're going to want to use this when the numbers are getting really large, okay? These numbers aren't really large, but I'm going to show you it on an easy one, and then if we have time, we'll do it on a hard one, okay? So we're going to do something that IXL calls least common denominator, okay? I've always called it least common multiple. It doesn't matter, okay? It is a sideways T-chart that looks like a stick sword. Multiples of 6. 6, 12, 18, 24, 30, 36. That's far enough, okay? Now remember I said this is least common denominator, right? So which one do they have in common? That's the smallest number on here. What? Somebody said 6, somebody said 12. Which one's smaller? 6. So we're going to use 6. Now we have to write it a different way, okay? So we're going to use 6 when we choose our denominator differently without multiplying them. You're going to need parentheses, okay? And my common denominator is 6. So do you see where I wrote the common denominator this time? It's down a row, okay? So this is how you will set it up when you choose your denominator by skip counting. All right, is this how you learn to do it, Mrs. Lowry? I mean, not draw it like that, but
similar, I think.
Similar, yeah. Okay, so now I take 1/3. Everybody look at the board. I'm going to put 1/3 here, and I'm going to put 1/6 here. And it's the same thing. We're making equivalent fractions. So we're going to multiply. Go ahead and write it. Okay, so 3 times what equals 6? Okay, put the 2 in there. So 1 times 2 goes here. Okay, 6 times what equals 6? So 1 times 1 goes there. And 2 plus 1 equals?
3.
And 3/6 is simplified to? Now, why would I want to do it this way instead of the other way? It's your choice. How about we try a different problem, and then maybe you can tell me why you want to do it this way. Does that sound good? So go to the very, very back of your page where it's blank. And we're going to write a problem down. So 7/12 plus 8/15. Flip it over to the very back and write this problem. it's a 5. Okay? And I don't know about you, but I don't want to have a denominator that is, gosh, more than 150. That's a huge number to be working with, okay? So that's why, because if I were to multiply these together, it'd be 150 plus 180. Am I right, Mrs. Lowry?
Yeah.
Okay, so that's too big. So I'm going to take the 12, and I'm going to take the 15, and I'm going to write the multiples. Because 15 times 10 would be 150, and 15 times 2 more would be, okay. All right, so you guys know your multiples of 12?
Yes.
Oh, let's sing it.
No.
Yeah, okay, here we go. 12, 24, 36, 48, 60, 72, 84, 96,
108, 120, 132, 144.
Excellent. So about how many of those do I need to write here? About 5. Okay, now the multiples of 15 aren't quite that easy, but I think we've talked about them before. 15 plus 15 is what? 30. Okay, so 15, 30. Then if I add another 15 to 30, what do I get? 45. Then what? 60. Okay, I think I can stop. So what's my least common denominator? 60. Circle it. That's a lot less than 180. Okay, so here's how I'm going to write it. Remember, we're going to have to make equivalent fractions. This will be 7/12, and this will be 8/15. And what was my common denominator? 60. Now on L3, this will come in handy for you because I saw some kids having huge numbers in their problems. So when you're working on L3 on IXL, use this, we're calling it the wooden sword method, okay? All right, so 12 times what equals 60? Oh, I wanted to show you something really cool. Are you ready?
Yeah.
If you don't know, you can just count. 1, 2, 3, 4, 5. So 12 times what equals 60? So 7 times 5, 35. That's your numerator. Okay? And 15 times what equals 60? 1, 2, 3, 4. Okay? So 8 times 4 is, oh my, it's a mixed number. So 35 plus 32 is 67. Okay, now remember the other day when I had you decompose? So take out one whole, that's 60 60ths. Okay, and how many are left over? 7 60ths. So my answer is 1 and 7 60ths. Okay, now that's a lot of work for one problem. But the older you get, the longer problems are going to take. Okay? I would much rather use the number 60 than I would 180. So especially on IXL, make sure you try this. Do we have time for another one? Not really. Okay. Good job today.
Yay!